Hello students, it's Mr. Wilsey. In this video we're going to be looking at the objective on solving systems of equations in Algebra 1. So let's look at problem number 1. Graph the system of equations shown right here on the grid below using a straight edge, and then we will mark the intersection point and then write the solution of the system as an ordered pair. So first of all, let's graph these two equations separately. So first of all, -4 is the y-intercept here, so I'm going to plop down a point. And then the slope is -1/2, so rise -1, run 2. Right? And then I'm just going to go in the opposite direction to extend my line. There we go. So we have our first line. Perfect. Now let's graph the second line. +2 is the y-intercept here. The slope is 5/2. So rise 5, run 2. Well, I don't have enough space up here, so I'm going to go in the opposite direction. I'm going to rise -5, run -2, and this point is also in a line, so I just went backwards. No problem there. Okay, so here's my system of equations graphically. Now, the intersection point is -2, -3. -2 is the x, -3 is the y. And that is the solution to the system of equations. X is -2, y is -3. There we go. Now let's look at the next problem. Graph the system of equations in your calculator and then write the solution of the system as an ordered pair. Okay, so here's our system of equations here. Now, in order to graph this, we're going to go to Doc, File, New. No, I don't want to save. Add a graph. Okay, so our first equation is y equals, so just leave it the way it is, -0.28 times x minus 5.23. Enter. So here's our first line. And then the next line is, so in order to get a new equation, we're going to press tab. Okay, so there's our second y. Y equals 8.37 times x minus 2.31. Okay, so there's our second line. Now, we need to find the ordered pair of the intersection point. So what we're going to do is we're going to go to Menu, Analyze Graph, Intersection. Now the lower bound, we're going to move our cursor over here so that it's to the left of the intersection point. Press. Upper bound, we're going to scroll over to the right. And our intersection point is right here. -0.338 is the x value. -0.338. The y value is -5.14. There we go. That is our ordered pair. Piece of cake. Now, let's do the same exact thing for the next one. So I'm going to go to File, New. No, don't save. Add another graph. So the first equation is 5/3 times x minus 25. Uh-oh. The graph doesn't show. Interesting. Curious. Let's go ahead and try to graph the second one. So press tab. So y equals -13 divided by 5 times x plus 23. So we get a little bit of the second line. It appears that we're not zoomed out far enough in order to see both lines and the intersection point. So what we're going to do is we're going to go to Menu. We're going to go to View. No, we're not. We're not going to go to View. We're going to go to Window/Zoom. And then zoom out. And then we're going to press Enter. There we go. So we zoomed out far enough to see the intersection point. And that was the point of this next problem, was to force you to use the zoom button. So again, Menu, Analyze Graph, Intersection, lower bound, upper bound, and the intersection point is highlighted for us. Okay, I'm just going to click on this, wiggle my finger, drag so we can see the intersection point's coordinates. Alright, so the x value is 11.3 and the y value is negative 6.25. Alright, that wasn't too bad. So we are done with the first page. Now, let's look at problem number 4. What is the solution to this system of equations? The equations are graphed for you. You don't have to do any work. So I have the equations over here, but you don't need them because I graphed them for you. The point of this problem is for you to recognize that the intersection point is the solution to the system of equations. So the ordered pair of the intersection point is -4, positive 1. -4, positive 1. That is the intersection point, which is the solution. Now, what is the solution to the system of equations graphed below? Again, we don't need these equations because we have the graphs. In this case, the two lines are parallel. They never intersect. That means there is no solution to the system of equations. Now let's look at the next line. Again, we have our equations, but we don't need them because we have the graph. Now this is an interesting case because the blue and the red lines are on top of each other, making purple. So when the lines are on top of each other, that means that these two equations have the same exact solutions. The same exact values for x and y will work for both of them, which means there's an infinite number of solutions. When the lines are on top of each other, we say that there's an infinite number of solutions. Alright, let's move on to the next one. Next page. How many solutions does the system of equations have? So we have our equations here, we don't have the graphs. Now, we could solve this in a couple different ways. We could find a way to graph the two equations by solving either equation for y. So the first one is already solved for y. We can graph that easily in our calculator. This one, we would need to solve for y. We could graph that. Now, the easiest way to do this is by graphing. So that's the way that I'm going to do it for you here. So first of all, file new, again, don't save, add a graph. Oops, I added a calculator. There we go. First equation is already solved for y, so I can plug it into the calculator directly. Y equals 1 divided by 2, so 1/2 times x plus 9. So there's our line up there. Now, how about this next one? We need to solve this second equation for y. So in order to do that, let's see, we need to add x to both sides. So 2y equals 1 plus x. And then finally we need to divide both sides by 2. We need to divide everything by 2, is another way of saying that. So this equation is going to be y equals 1/2 plus x over 2. Now I'm just going to rearrange this so that it looks like it's in y-intercept form again. X over 2 is the same exact thing as 1/2 x, and then plus 1/2 is the y-intercept. Oh, duh. You could also, a third way is to simply look at the equations and recognize that they have the same slope, but they have different y-intercepts. So if the lines have the same slope, they are parallel. If they have different y-intercepts, they're not on top of each other, which means we're going to get a situation like this. Okay? These two lines have the same slope, so they're parallel, but they have different y-intercepts. So automatically, just based on what I see here, I don't even need to graph these lines. I can say that there's no solution, because they're going to look something like this. They're going to be parallel. Right, here's x, here's y. And then down here, you needed to explain how you made your conclusion, and in this case our conclusion is exactly what I said. You can just simply look at the equations. Alright, let's do the same thing down here. I'm going to try to solve both equations for y. Now this one, 6y equals 2x minus 14, all we need to do is divide everything by 6. So y equals 2x over 6. Simplest way to write that is 1/3 times x. And then 14 over 6, we can't really simplify that a whole lot. We could take out a 2 from the top and the bottom, so minus 7 over 3. Okay? So that is the first equation, solved for y. Now let's solve the second equation for y. In this case, all we need to do is just divide everything by 3. So y equals negative 7 over 3, and then x over 3. Now I'm going to write this a little bit prettier over here. Sorry, I'm running out of space. Y equals, I'm going to write the x part first. X over 3 is the same thing as 1 over 3 times x minus 7 over 3. So that is our second equation. Now that probably looks familiar, because that looks identical to the first equation. The equations are the same. They have the same slope and the same y-intercept. That means that we're going to get a situation like this. These two lines have the same slope, the same y-intercept. That means they're the same line. That means that there's an infinite number of solutions to that system of equations. Infinite number of solutions. They are the same line. Okay? And we just looked at the equations. Okay? Method 3. Now finally, let's look at number 9. We are given an ordered pair. We are asked, is that the solution to this system of equations? And then we need to show work to justify our answer. Now the easiest thing to do here is to simply plug in that ordered pair into both equations to see if they make both equations true. So negative 4 is the x, 2 is the y. So let's look at the first equation. Negative 3 times x is negative 4, plus 2 times y is 2. Is that equal to 16? Question mark. Let's see. Negative 3 times negative 4 is positive 12, plus 4. Yeah, 12 plus 4 is 16. So that checks out. But we're not done yet. We need to plug in the ordered pair into the second equation now. So 1/4 times the x value is negative 4, minus the y value is 2. Is that equal to negative 3? Well, let's see. 1/4 of negative 4 is negative 1 minus 2. Yeah, negative 1 minus 2 is indeed equal to negative 3. So the ordered pair works for both equations. So, yes, it is a solution to this system of equations. Now that, we have a little bit more. We have the word problems now. Now let's look at number 10, a word problem. Ew, word problems. A student club from the L&N STEM Academy is selling boxes of baked goods to raise money. Each box costs $4.50 to make. So I'm just going to write that number out, $4.50. And the students sell each box for $6. The students pay $120 for supplies, spatulas, baking sheets, oven mitts, and aprons, blah, blah, blah. How many boxes do the students need to sell in order to break even? Now remember that break even means that their income is equal to their expenses. So right there, income equal to expenses, that screams out to me an equation. I'm going to write that equation out in words. Income equals expenses. Now, the unknown in this problem is how many boxes do the students need to sell? So I'm going to let B represent the number of boxes that they need to sell in order for their income to equal their expenses. Now let's think of a way to write the income in terms of B and maybe some of these numbers that we saw in the problem. Well, let's see. They sell each box for $6, so it seems that if I multiply $6 by the number of boxes, I get the total income, right? $6 times the number of boxes gives the income. $6 per box times the number of boxes. Now let's think about the expenses. Let's see. It costs $4.50 for the students to make each box, and then we have $120, which does not depend on the number of boxes that we make. It's just a flat charge for all of our supplies. So it seems like the expenses would be $4.50, or 4.5, times the number of boxes. Okay, 4.5 times the number of boxes, plus 120. Okay, so that's our total expenses, and that's our income. Now we have an equation with one variable. I can solve this equation. Okay, so let's bring the b over to the left side. Let's subtract 4.5b from both sides. 6b minus 4.5b is 1.5b is equal to 120. And then finally divide both sides by 1.5. So b is equal to 120 divided by 1.5. 80. B equals 80. So that means that we need to sell 80 boxes in order to break even. We need to sell more than 80 boxes in order to actually make more money than we have to spend. Okay, let's look at the last problem here. I have 51 coins, pennies and nickels only, worth a total of $1.79. How many pennies do I have? How many nickels do I have? Okay, so there's two parts of this problem. Now, first of all, our unknowns, just like in the last problem, our unknown was the number of boxes. Our unknowns are the number of pennies, so I'm just going to represent that by P, and then how many nickels, N. Now, it gives us a hint here. It may help you to write a system of two equations. One equation represents the total number of coins, the other equation will represent the total dollar amount. And then we can solve the system of equations using any method we want. Now, the number of coins equation, let's see. How can we combine P, N, and maybe some numbers we see in the problem in order to come up with an equation that represents the total number of coins? Well, let's see. I know that I have a total of 51 coins, and P is the number of pennies, N is the number of nickels. So it seems that if I just take P plus N, that's going to be equal to 51, right? Number of pennies plus number of nickels equals 51. Okay, so that's a piece of cake. Now let's think about the dollar amount equation. Let's write another equation. Let's see, the total dollar amount is $1.79. Okay, now how do I combine P and N and some other numbers in the problem? There's no other numbers in the problem. I've used them all. But there's some hidden numbers in the problem. How much is a penny worth? Well, a penny is worth 1 cent, but this is in dollars. 1.79 is in dollars. So let's write 1 cent in dollars. $0.01 dollars. Same thing with a nickel. A nickel is 5 cents, but that is $0.05 dollars. Okay? So we can combine P and N to get the $1.79, but we need to multiply each one by how much a penny is worth, how much a nickel is worth, right? So watch this. 0.01, so $0.01 dollars times the number of pennies gives the total dollar amount of pennies, plus 0.05 times the number of nickels gives the total dollar amount of nickels, and that whole thing should be equal to the total dollar amount of all of my coins, $1.79. Okay? So now we have two equations with two variables. I have a system of equations. Now let's try to find the solution to this system of equations. Well, let's see. What's going to be the easiest thing to do here? We could do substitution. But honestly, I just want to use the calculator. Watch this. I'm going to show a trick. So be in the calculator screen here, and then we're going to go to Menu, Algebra, Solve System of Linear Equations. Yeah, I love it. Okay, so I need to type my two equations here. Let's see. P plus N equals 51. That's my first equation. My second equation is 0.01 times P plus 0.05 times N equals 1.79. Okay? I'm going to need to change my X and Y because I have P and N. So change X into P and change Y into N. Enter. Hey, look at that. 19 and 32. Now 19 is in the P slot, so P is 19. So I have 19 pennies and I have 32 nickels. That was a piece of cake, right? The most difficult part was just writing the equations. Okay, so that is it for this objective. Hope you learned something.